Yeah, good afternoon. So it's been some time we met, and I'm happy to meet you again. And I just wanted to discuss some problems on the topic of magnetic force. Important topic. You might have read about magnetic force by now. Just a quick revision. So before we do that, let's try to understand the sense of direction. Now, you know that if you have a charge which enters a magnetic field, which means the charge has a velocity with respect to the magnetic field, the charge will experience a force. Okay, that force is what we are referring to. So if you have to write that force vectorially, it is F is equal to Q, and it is V cross B. Okay. So this is a vector product, and this is called as magnetic force on a charge Q. This charge has to be a positive charge, okay? So the formula is meant for positive charges. If you're given a negative charge, like an electron, reverse the direction of force, okay? So always assume Q to be, like a positive charge. So this is for positive charges. If you get a negative charge, reverse the direction, okay? Reverse the direction of force, okay? And because we're doing a revision, that this particular force, the direction of this force is obtained using the right hand rule, okay? Now, this is also clear to us that this is right hand rule. But I'm just going to do a revision at a very conceptual level. So if I draw a diagram that shows you in 3D, if you have this coordinate axis, and you have this as, your x-axis, this is your y-axis, and this is your z-axis. If you look into this, the way that things work out is that the magnetic field, will have a direction. Okay, we can assume any direction here. Okay, so let's assume the magnetic field is in, upward direction. So let's say the magnetic field aligns with y-axis. So this is the direction of magnetic field. Okay, now it is upwards. So the y-axis, corresponds to magnetic field. Okay, this is one. And now let's talk about the velocity of projection, which means the velocity v with which let's assume electron, enters the magnetic field. So say the electron enters the magnetic field in a particular way, which is parallel to x-axis. So this is the way, you project your electron. And if I were to, extend the x-axis, this is the way I will extend it. So this is my x-axis, and this is my x dash, and I'm projecting my electron in positive x-axis direction. Okay. Now, if you look into the right-hand rule, you remember that this finger, represents, the middle finger is your magnetic field. This finger is your velocity, and this finger is your direction of force. So we know that magnetic field is upward, so I made it upward. I made the velocity, towards the positive axis. But I know in my mind that it's an electron, okay? So whatever direction I get, I have to reverse it. So if my magnetic field is upward, my, electron velocity is in this direction, and my force is coming out to be, towards the z-axis, I have to actually reverse the direction of force and take the direction of force to be, the other side of z-axis, which is, here. So if I were to show the force, actually the force is in this direction, okay? That's my force. So if I were to draw this on a coordinate axis, my magnetic field is upward. The velocity, of the electron is in this direction. So this is V and this is B. And if I use this concept, my field is this in my force, which is in the third direction, comes out to be like this, but I have to invert it because it's an electron and the rule is valid for, so I get this as my direction of force, which means, okay, by the way, and here is a concept. So I just wanted to show you this is a real direction of the magnetic field because we have to invert it because this is an electron and the rule is valid for positive charges. Now here is a deal. Now remember that force and velocity are perpendicular to each other in this case. So I will just draw a right angle triangle here and say, this, not a triangle, this is an angle. So this is 90 degrees. And we know whenever force and velocity are perpendicular, the kind of motion, the curve motion we get is the circular motion. So QVB, because V has been projected at right angles, we can write this as QVB, sine of 90 degrees, because the angle between V and B is 90 degrees. So I've written 90. If electron charge is known to you, the velocity of electron is known, magnetic field is known, the magnitude of magnetic force comes into picture. But what about direction? If you look into this figure, we know that this is a situation where the magnetic field force is essentially nothing but a centripetal force where the force and velocity are perpendicular to each other. If you look into the direction of force, which is this, and the direction of velocity is like this, the kind of circle you get because of this, would look like this. So if I were to draw this circle, and imagine, I have, a force which is acting like this, which is this, and a velocity at some instant, is at 90 degrees, tangentially. So I am getting a circle, which is going to be, like this, okay? But remember the direction of magnetic field is still upwards, which is this, okay? This is the direction of magnetic field. This is my direction of magnetic field, and my velocity vector at some instant here is V, and my centripetal force is V. So if the electron has reached here, the centripetal force is in this direction towards the center of the circle. The velocity vector is again at right angle. If you're here, your centripetal force is here, and your velocity vector is here. Now remember, if I draw this circle completely, this will look like, a circle. So in terms of plane, if this is your y-axis, this is your, the x-plane, which is this, and you have one more plane, which is the force, which is this. The force is in z-axis plane, okay? So if I were to mark this, this is, positive x, this is y, and the force is in z dash direction. So you can see the electron is actually moving in xz axis, which is because the magnetic field is upward in y-axis and the force and velocity are acting in z and x-axis respectively. And if you see the direction, it is counterclockwise. So this is the insight I wanted to bring in, that the circle is like this. This is xz plane and the magnetic field is upward in the y-axis, and this is your, the sense of direction which, you get in the plane. So this is xz plane. The circle, is in xz plane, and the magnetic field is upward. So you should, when you're solving these problems, you must understand the sense of direction and the planes in which all of this is happening. This is just not about, some QVB and some, trying to do that. You must have very good sense of this, the direction or the planes which are involved. So you can see here the electron is moving in xz plane counterclockwise, and the magnetic field is upwards. So I hope this gave you a good revision of right-hand rule, the concept of vector product, and how do you apply magnetic field force on a moving charge. This was a simple example of circle, and if the same charge enters at an angle, then you have a helical motion, which we can discuss again. But right now, keep your focus on the sense of direction of velocity B and the resultant force due to the relative motion of the charge with respect to the magnetic field, and see what plane is the electron moving in. You can get these questions in NEET examination and JEE Mains and JEE Advanced or BitSat or AP Physics or Cambridge or IB Board, where they're not only trying to test your knowledge of this expression, but also trying to understand whether you can analyze the direction and planes. Thank you very much.